Millions of dollars literally evaporate inside modern enterprises every single quarter. Why? Failed workflow automation. We see companies injecting artificial intelligence into their daily operations, expecting this frictionless revolution, but instead they end up engineering silent, unmanageable catastrophes. The financial and operational stakes of these misfires are absolutely staggering. So, in this explainer, we are auditing the exact anatomy of that collapse.
Look at this number. Over 20. A recent independent audit analyzed over 20 separate, entirely failed AI automation projects across different organizations. We are talking about companies that tried to automate operations, got severely burned, and literally had to tear their systems down to the studs just to understand what went wrong. And the core revelation from this autopsy, it's absolute. The collapse had absolutely nothing to do with the chosen AI model. The technology worked exactly as it was instructed to.
The AI just encoded the existing confusion at machine speed. Let that sink in for a second. This is the catastrophic reality of applying artificial intelligence to an unmapped, undocumented business workflow. When you throw advanced tech at a chaotic human process, the AI doesn't magically organize the chaos. No, it simply executes your existing dysfunction faster. It scales bad logic with relentless efficiency.
Okay, let's move to Section 1, Systemic Failure Vectors. Vector 1, Undocumented Workflows. The consistency of this first vector across the audit was genuinely striking. In every single post-mortem we looked at, the failed team attempted to automate a process they hadn't actually mapped out. Basically, they automated their assumptions. There is a hard, unbreakable operational rule here. If a business process cannot be drawn on a whiteboard in 10 minutes, it can't be automated. You simply cannot write code for an action you can't describe.
Then we have Vector 2, what we call the evaluation void. This is incredibly dangerous operationally. Teams were deploying automations where the only feedback signals were totally extreme. Either it broke entirely or seems fine. Nobody was spot-checking the daily outputs. Why? Because nobody had bothered to define what correct actually looked like before the system went live. And when you lack a predefined rubric, silent damage scales entirely unsupervised in the background.
Let's look at the mathematical reality of that silent damage. Imagine a simple automation handling 500 daily tasks. Now apply a seemingly negligible 3% hallucination rate to that volume. That is 15 wrong outputs generated every single day. Sure, in a quick controlled demo, 15 errors, that's just noise. But deploy that over weeks and months, that compounding interest of invisible failures becomes a toxic business process that is literally poisoning your own database.
Vector 3 is improper prioritization. Executives routinely fall into this trap of automating the loudest complaints rather than the highest leverage workflows. Say the CEO complains about the manual formatting of a weekly report. Well, that highly visible annoyance gets automated immediately, right? Meanwhile, a high-stakes disaster like undocumented lead routing, something that directly impacts revenue, is completely ignored simply because it operates quietly in the background.
So how do we solve that? We rely on a strict mathematical formula. Priority equals the error rate, multiplied by the volume of the task, multiplied by the cost per error. This stark equation forces leadership to target the quiet, repetitive, high-leverage workflows that actually yield a return on investment. The math dictates the strategy here. It's the only way to eliminate emotional bias from your engineering pipeline.
Moving on to Section 2, Hidden Systemic Friction. There is a stark contrast in how you diagnose failure. Think about it. When a human operator makes a repetitive mistake, you can simply walk up to their desk and ask them, "Hey, why did you do that?" You find the misunderstanding immediately. But when an automated system makes a mistake, the diagnostic friction is immense. You're forced to reverse engineer an entire frozen system just to isolate the exact line of code where a flawed human assumption was permanently baked in.
And this leads directly to the danger of automated tribal knowledge. When you automate an undocumented process, you freeze it. It becomes this rigid system that nobody fully owns, and frankly, nobody knows how to update when business conditions inevitably change. The source data provides a chilling real-world example of this. One company deployed a lead scoring automation that ran confidently wrong on 8% of its outputs for 6 straight weeks. Why? Because the sales reps simply trusted the machine output by default. They just assumed the AI knew better than they did. Then there's the missing exception path. A truly critical architectural failure. Engineering teams will meticulously define what happens when an automation succeeds, but they completely ignore what happens when it's unsure, or missing data, or just blocked. Teams avoid designing for failure because it kind of feels like admitting the automation is flawed. But in reality, architecting a clear, safe route for low-confidence outputs is literally the only way to ensure the system doesn't cause catastrophic damage.
Section 3. Tactical Implementation Framework.
Step 1 is an absolute prerequisite: process mining and discovery. Teams have to utilize process mining software, tools like Celonis or similar enterprise platforms, to map what the workflow actually looks like in the raw data. Human operators will tell you how they think the process works, but the process mining UI will reveal the actual bottlenecks, the shadow IT, the weird deviations. You have to automate the reality, never the assumption.
Once your discovery is complete, you command your engineering teams through this strict, sequential pipeline. Map the workflow completely. Define what a correct output is in granular detail. Automate the visibility of those outputs. Add your exception handling for failure states. Measure absolutely everything from day one. And only after all of those gates are cleared do you increase the system's autonomy. Skipping even a single gate here guarantees the exact post-mortem failures we analyzed earlier.
Furthermore, oversight cannot just be a manual task assigned to an already overworked manager. You must implement continuous automated oversight. Treat the evaluation layer as a scheduled script, like a cron job that automatically samples 5 to 10% of outputs daily, scores them against your pre-launch rubric, and triggers an immediate alert if the pass rate drops. This architectural choice catches model drift in week 1. It cleanly eliminates the possibility of 6 months of invisible rot.
So as we wrap up this explainer, I'll leave you with a definitive architectural question. Think about your own systems right now. If your automation encounters an undocumented edge case today, does it silently guess and fail? Or does it cleanly route that low-confidence output to a human fallback? A system designed with a deliberate, mapped exception path is the only system you can ever trust to run unsupervised. Anything else is just a ticking clock.
Ultimately, building without these guardrails is essentially automating your own funeral. You are architecting a highly complex machine that functions perfectly right up until the exact moment it abruptly crashes. You have to design for the failure path, or I promise you, the failure path will design your future.